Hi, Michael and Denali. This is Dan, and I wanted to give you a little quick lecture, kind of a repeat of what happened in class today. Kind of important because we're into chapters 8 and 9, and that's kind of the beef of the class. We do IP addressing, and then chapter 9 we'll do subnetting. So a lot of kind of what we did today was binary to decimal conversion, which I think you're really comfortable with. So I'm not going to repeat that. If you have problems with that, let me know and I can review it. But I believe you did that in 98, and I'm pretty confident that you have going from um, decimal to binary using the weighted column system, and vice versa, going from binary to decimal, decimal to binary. So hopefully you've got that down. Because the key is that I mentioned in class, I believe last week, as we start working with both IPv4 and IPv6 addresses, especially when we do subnetting with IPv4, is working in binary reveals everything. If you're willing to convert the IP address and the subnet mask into its binary notation, then network and host portions reveal themselves. And I mentioned in the class today that Cisco loves to trick you. There aren't obvious boundaries when you're working in dot decimal, and we'll see why in just a moment. So the reason that we want to use our subnet mask and our IP addressing as we've done here, here's an IP address, and the subnet mask reveals what portion of the IP address is the network portion and what portion is the host portion. So the anywhere where there is a 1 bit in the subnet mask, that bit in the IP address is a network bit. Anywhere where there's a 0 in the subnet mask, that relative bit in the IP address is a host bit. We need to remember that the subnet mask itself is not an address. It's not something that's routable. It basically is just saying, hey, which of these bits up here are network, part of the network address, and which of these bits are part of the host address. That's all they're telling us. And in this particular example, the subnet mask is showing us that the first 3 octets are network octets, and the last octet is a host octet. So a very simple example. In the subnet, the network bits do not need to fall along octet boundaries. So that's where Cisco will kind of try to trick you in the exams. So if you practice this stuff, it's very revealing. So here is just a couple examples where we're using slash notation to say, when we see slash notation, that number indicates the number of 1 bits in the subnet mask or the number of network bits in the subnet mask. So then that tells us over here that, okay, the first 3 octets are network portion of the address, and then the last 8 bits are host bits. And so if we do a 25, well, now we're seeing where we're kind of going beyond the dot decimal boundary. The dot decimal is just a way of packaging to make it easier for us to input IP numbers and to track IP numbers. The computer works in binary. And so when we put things in binary, it reveals itself. That's how the routers do it. So we have to remember that dot decimal. Don't try to, as I've mentioned probably several times, don't try to ascertain things by looking at the dot decimal. Convert it to its binary and it will reveal itself. So here's a situation where we actually have 25 network bits, which means that first bit in the last octet is actually a network bit. So you can get something that Cisco is going to ask you is going to say, hey, is this a host address, a network address, or a broadcast address? And we know the definition of a network address is simply all host bits are 0. The definition of a broadcast address is all host bits are 1. And anything else where if all the host bits aren't 0 and all the host bits aren't 1, then it's a host address. And typically, for example, when we see 255, we want to say, hey, that's a broadcast address. So when we see this, we say, oh, that's not a broadcast address because it's not a 255. But we have to look at that subnet mask, put it in binary, and when we write it out in binary and put the 127 in there, we'd say, oh, I only have 7 host bits, and guess what? All those host bits are 1s, therefore it is a broadcast address. Here's another example where we're going across our boundaries. 26, that means we're grabbing the first 2 bits in that last octet, and those are part of the network address, the network portion, and then I'm left with 6 bits that are the host portion. And so again, all host bits are 0. This piece is a network address, so 10.1.1.0 is a network address. 10.1.1.63 is a broadcast address because all the host bits are 1s. So again, we don't want to try to ascertain and make assumptions based on looking at the dot decimal. Use the subnet mask and the address in binary, and it's going to reveal itself. And this is just more of the same, where we're using 27 and using 28 to go across those boundaries. So again, just reiterating what I mentioned before, when we look at, there's 3 different types of addresses that we look for here. I'm trying to find my mouse. We're looking for a network address, a host address, and a broadcast address. So by definition, network address, all host bits are 0. Broadcast address, all host bits are 1. And again, we don't want to look at this dot decimal number and make an assumption. And a host address, it's a combination of zeros and 1. So those are typically if Cisco's going to ask you a question, they're going to give you an address. They'll give you something like we have up here and say, hey, is that a network address, a host address, or a broadcast address? And so you will need to use the subnet mask and then do it in binary and determine what that is. And if you do it in binary, it's very easy. And they'll try to trick you, so you want to kind of be careful to not assume and look at the number and assume it's a 255 or that there's a 0 in the last host bit, and therefore it's a broadcast or network address, respectively. The other thing that they're going to ask you for a particular network address is they're going to ask you what is the first host address and what is the last host address. So first and last. So the first host address is simply we represent the number 1 using all the host bits, whether it's 2, 4, 8, 16, 24. We put all those host bits together, and if the value is 1, that is the first usable address. The last usable address is simply the broadcast address minus 1. We turn off that rightmost bit. This is now a host address because all the host bits are not 1 and all the host bits are not 0. Therefore, by definition, that is a host address. Excuse me. So the things that they're going to ask for are, given this particular network address, what is the first host address? What is the last host address? What is the network address? And what is the broadcast? Well, network address they give us. First host address, simply take the host bits and set the rightmost to 1 and the rest is 0. Last host address, simply take the broadcast and flip that rightmost bit to a 0, and that's the last. And then the broadcast address is just you make that one a 1 so that we're 1s across the board there. This slide I think we talked about last week, and it's simply dealing with, well, how does the router do it? Well, the router works in binary. All computers work in binary at their most basic level. They're going to convert everything to 0s and 1s, and then they use an AND circuit, or what's called an AND gate, and they literally do a Boolean AND. By doing a Boolean AND, if there's 2 1s in the expression, then the result will be 1. But if there's a 0 anywhere in the expression, any of the operands are 0, the result will be 0. And therefore, when we use in the subnet mask, because we use 0 to represent the host portion of the address, anytime we AND that, whether it's a 0 or 1, we're going to get a result of 0. So we're able to filter those out. Then in the network portion, 0 and 1, everything's 1, so 0 and 1 preserves the 0 in the address. 1 and 1 preserves the 1 in the address, so that network portion basically falls through, and we can see that they are equal. And so we're able to basically filter out the network portion or the network bits from the host bits and basically get rid of the host bits altogether. And the router actually works with the network portion to determine where it needs to go. So last slide here. And that's just talking about private address blocks. So private address blocks were introduced primarily to save IPv4 addresses, because one of the issues that we had is we quickly ran out of IP4 addresses. And one of the reasons for that is when we first came out and started using the internet, large companies that were getting into it, Coca-Cola, that just comes to mind. I mean, they would get a Class A, what's called a Class A address, which is talked about in your chapter, which basically gave them over 16 million host addresses, because the first octet was the network portion, but they then had 24 bits for the host portion, and then 2 to the 24, I believe if you do the math, is 16 million and change. And so if they only used 500 of those, there was quite a few that were wasted. So we quickly ran out of IPv4 addresses. In fact, we are officially out of IPv4 addresses, hence the move to IPv6 is being pushed. But what we have is we have what are called private addresses. So private addresses allow us to reuse addresses inside our network, and that's where you'll see the real popular 192.168. So those are routable inside the network, but they're not globally routable. So out there on the internet, they will not get routed, they will get dropped. And so there are 3 different ranges of private addresses. There's the 10.0 range, which we go 10.0 to 10.255.255.255 using subnet mask of 8. There is the 172 range, and notice that's 172.16 to 172.31. So that's a subnet mask of 12, which means we're using all the first octet for the subnet mask for the network, and then only 4 bits out of the second octet. So the last 4 bits out of that second octet are host bits. And if we turn these on, so this is set to 16, so this bit is turned on. And if we turn all these on as a host, that you'll get 15, hence you get the 31 there. So if that didn't make sense, I can explain that to you when you're back in class. And then 192.168, the first 2 octets are for the network, and then there's 16, so the second 2 octets are used for the host bits. So that basically is a quick synopsis of today's lecture. Again, we spent quite a bit of time working on binary to decimal and decimal to binary conversion for folks where that it was new, and then just kind of talked about the IP addressing. So on Thursday, we'll actually do a couple of labs that deal with this, and you're welcome to get started on those, because those labs are just what I call paper pencil. There's no equipment that we need. We don't need our racks or Wireshark or our virtual machines. So that's something you can actually, as you're studying this before Thursday, I would go ahead and open up those labs and practice, and then we'll do that Thursday as well. And then also on Thursday, I'll start the hour with talking about IPv6. So if you have any questions, drop me a line. Hope you feel better, and you guys take care.